Hello and welcome to part 8 of Dev Maths and Stats Refresher Course Lecture 1, in which we look at completing the square. So completing the square, a very useful little technique. I'm just going to do this. This just removes an earlier assumption that m is greater than 0. This is a really useful technique for finding maximum and minimum points, which can sometimes be quicker and easier than doing calculus. But it depends on recognising a pattern for a perfect square. So if you see an equation like this, so you've got 36 is a square number, 6 squared, 4 is a square number, but also you need to notice that this 24 in the middle, just by chance, it happens to be equal to 6 times 2 doubled, so 6 times 2 times 2. So it's twice the product of 6 and 2. In that case, you can factorise it into this form. And you should be able to verify that this times this does indeed give you that. So if you multiply the brackets together, you get that. You should be able to check that. And also, instead of writing in this form, you can write it like this. So this is a perfect square. And just to check, you can get Mabel to expand the bracket. It does work, okay. So, the problem with this is that many times you don't get a perfect square, because this is just really luck. Many times you have something like this, which is not a perfect square. However, what you can always do is this trick. If I take this and write it like that, you can see this is exactly the same thing. Now, this part is a perfect square, and I just have to add 8s to it. So this I can put into the perfect square form. I just have plus 8 on the end. Once I've done that, I can really easily find the minimum value of this expression. Because 8 is fixed, the minimum possible value this can have is 0 because it's a square, so it can only go as far as 0. And when does this get to 0? It's when m is equal to negative a third, or plus a third, in fact, plus a third, okay? So when m is a third, I'll get the minimum value, which is going to be 8. Now Mabel can do this for us. With just means it loads some command, and with student it loads in the package of commands for student for some reason, which are these. And then this, complete the square, gives you that. You should be able to tell that this is the same as the version we've got here. So if when you put this 36 inside the square bracket, you have to square root it. So 6m, so it's the same as putting 6 inside there. Okay. And again, here you should be able to do these by pen and paper. So this one. So if you complete the square here, you get that. This one here. So you can do these at your own pace. You can stop the video, work these out. If you have Mabel, you want to see the answers, then you have to change that into a semicolon and press the return key. You get the answers. Before we do that, I'm going to do, I think, this one by hand. So if you like, please feel free to fast forward through this part. So I'll copy this as before. Take it onto this sheet here. I bet try and paste it in. I found that many times when I teach this course, I spend a lot of time confusing myself and confusing the students because I don't write the answer, I don't write the question down correctly, so I want to make sure I get the correct question. Otherwise it is hard to get the correct answer. So here we have 4x squared minus 40x plus 150. And I want to put it into this form of a squared thing plus or minus some unknown thing here. So this could be minus, so it's going to have to be 2x. It must be 2x because 2x squared gives you 4x squared. and then this number multiplied together must give you half of this. That must give you negative 20. So this times this must give you negative 20. So here I must have negative 10. I was going to put it in black. Oh gosh. So that must be negative 10. So 2 times negative 10 is negative 20. And when I multiply the brackets out, there will be 2 of those. So I'll get minus 40. So that's fine. That all works. And then I know what I must have here because this must give me the negative 4. I know what I have here because this times this must give me negative 20 to get the negative 40. But when I find this squared will give me plus 100. And that's incorrect. Yeah. So what I'll need to do here is to add on 50. So this will now give me this part, and this part, because I have the 50 here. So 100 plus 50. Let's get that part. Yeah. So what you find is that what you put inside the bracket is determined by this part here. So you choose these numbers to give you the correct answers here, and then you adjust it with this plus or minus to make this one correct. So you can always do that, and you can always find a way of completing the square. Go back to these. Let me just go through and show you the answers to those. So I'm going to show all the answers now, so please pause the video if you don't want the answers quite yet. And feel free to ask me in the problems class or elsewhere if you're not sure about any of those. Okay, so completing the square is also the basis for solving any quadratic equation. So if we take the last one we did, the last example, which is this one, let's say I want to solve that equation. So now I've taken this and said this is equal to 0. If I want to complete the square, if I want to solve that and find what value of x makes that true, one way of doing it is to complete the square on the left hand side to find this. And now I can solve that using the golden rule step. So if I remove the fraction by multiplying by 16, I remove the fraction, then add this to both sides, then divide by 1024, this, then take the square root, both sides, so you have x plus 5 over 32 has got to be equal to this, or it could be equal to a negative, because there are 2 possible ways of solutions to this. When you take the square root, it could be positive 11 over 32 or negative 11 over 32 when you square root this. So solving these 2, so I've removed the fraction by multiplying by 32, then I've removed the 5 from each of them, and then I've divided by the 32. You find x is either 3 over 16 or negative 1 over 2. I substitute back in to the original equations to check, so it does work by substituting back in. So I found from my quadratic equation like this, I found there are 2 possible values of x which solve this equation, and these values are positive 3 over 16 or negative 1/2. Now, just as a piece of interest, you can actually do this to solve the general quadratic equation, And I'm going to do this quite quickly because it's not something I'd ask you to do, but it's just to show you the application of this. This first thing just clears the earlier assumptions, so you won't get those squiggles anymore. So if I want to solve that equation, if I complete the square, you find that, if you want, you can go through the steps of finding that. It's quite hard to get Mabel to do it, but you can do it by pen and paper, and then just step through and solve that equation. So first, I'm moving these things to the right-hand side. Moving these to the right-hand side, then I'll divide by a. Yeah. Then I'll take the square roots. Take the square roots and then multiply by 2a to clear that from the bottom, and so on. And then multiply by 2a, then remove the b's, and then divide by the 2a. Yeah. And you find this. Now, I imagine that if you think back to when you were studying maths last at school, you've seen this before. And this is indeed the standard formula for the solutions for a quadratic equation. So this is the way we get that standard formula for a quadratic equation, is just by completing the square. And then you can check that it works by substituting it back in. That's applying this to the one that we solved earlier. So where a is 64, b is 20, and c is minus 6. So a, b, and c are A, B, and C are these numbers. So in this example, A is 64, B is 20, and B is minus 6. If you substitute that into this formula, you'll get the two answers we found before. I saved that for later use. Okay, so in the next short video, we're going to look at simultaneous equations to remind you of those. Thanks for watching.